Now, thinking back to our two reactions we looked at the very beginning, we looked at an endothermic and an exothermic reaction. And I would ask you, how would you increase the rates of reaction for these processes? So pause the video for a second and jot down a few ideas. Now, the first way we can increase a reaction rate is simply change the reactants. Now, this one isn't something I would expect you guys to write down, and it wouldn't be something, as I ask you guys, how would you increase the rate of these reactions? Changing the reactants wouldn't really be allowable considering how I pose the question. But the idea of increasing a reaction rate, you can make a reaction faster if you have different stuff. So that's just a fundamental concept that some reactions happen faster than others because of the nature of the reactants. Now, second, the concentration of the reactants. If you put more reactants there, it would react faster just by the statistical probability of collisions. If you have more stuff there, there will be more collisions. So, because you're increasing the total number of collisions, you'll increase the total number of successful collisions. So increasing the concentration of the reactants generally increases reaction rate. This next one's a bit tricky. Temperature almost always increases reaction rate. Now, thinking back to thermodynamics and to Le Chatelier's principle, you may have only said that temperature would increase the rate of the reaction for the endothermic process. And we're actually talking about two different things. In an endothermic process, increasing temperature shifts the reaction towards the products, increasing the ratio of products to reactants at equilibrium. I'm not asking you that question here. Kinetics has nothing to do with how many products and how many reactants you have. Kinetics is just the idea of how fast it takes you to get wherever it is you're going. Kinetics doesn't really concern itself with exactly where you're going. Temperature, increasing the temperature makes almost every reaction faster because every reaction almost has an activation energy. Increasing temperature increases the available energy, increasing the percentage of successful collisions that occur. So for an endothermic or an exothermic process, increasing temperature almost always makes the reaction faster. It doesn't tell you how much products you have, just the speed. Next, increasing the amount of surface area you have increases the rate of reaction generally. Because four things just successfully collide, they have to hit each other with enough energy to overcome the activation energy and in the proper orientation. If you increase the surface area of a reactant, you're simply increasing the probability that something will run into it. So you're increasing the total number of collisions, thereby increasing the total number of successful collisions. How you do that practically would be sort of mashing it up. If you have large crystals, they're going to be more likely to react if you smash them up than if you leave them clumped as one large crystal. That's why if you drink hot coffee or hot tea, sugar dissolves faster in just normal crystals than in a sugar cube. A sugar cube takes longer to dissolve than just normal sugar crystals because the surface area is smaller. So smashing up a sugar cube would make it dissolve faster, which I'm sure you know from experience. Just swirling your spoon around makes it happen faster. Next, a catalyst. As you guys are probably already familiar, a catalyst increases the rate of reaction by lowering the activation energy of the process. Finally, on factors that affect reaction rates, one small note, it likely won't even come up, but this was something that they used to trip students up on the old AP test. It may not be anything that they test you on in the new AP test, just a small side note. Adding an inert gas, so a non-reactive gas, like helium or nitrogen or something like that, won't change the rate of reaction. If you have, one of the reactions we looked at that has nothing to do with a gas that's added and you think, wow, why should adding hydrogen do anything? It probably doesn't in terms of reaction rates. So, just one small note, don't worry about those things.